Hi, so I just want to take a second to go through a couple examples from the 1.3 homework. So the first problem we'll look at from section 1.3 is just problem number 13. And it's asking us to evaluate the limit. Whenever I'm asked to evaluate a limit, the first thing I do to see if I can evaluate it is to apply direct substitution. Now we're going to talk about in a later section, what allows for direct substitution, but I just always try direct substitution first. So since we're looking at the limit of x approaching 4, I'm going to directly substitute 4 in for x and then evaluate. When I do that, I have 16 plus 8 minus 24 in the numerator. And in the denominator, I have 16 minus 16. So we can, continue evaluating that denominator, but what I see very quickly is that I end up having 0 in the denominator. And so right away, that tells me it's not defined. This expression is not defined when x equals 4. So direct substitution is not possible. So we have to go a different route. So what I like to do then is to see if, okay, maybe direct substitution is not possible, but we have the theorem that says if you can find a function that agrees with your given function at all but one point, then their limits are going to be equivalent for all values of x. So really, if I can find a way to find an equivalent function to this, I can look at possibly evaluating the limit. So the way that I do that is I factor the numerator. And so I'm not going to review factoring, but if you do have questions on how to factor, you can always send me an email and I'll go ahead and review that in a different video for you. But let's just go ahead and factor. The numerator factors to be x minus 6, x plus 4. Just kidding, x plus 6, x minus 4 over the quantity x minus 4, x plus 4. Now, the next thing that we want to do, just remembering our college algebra days, or we want to then cancel out common factors. When we cancel out the common factors, we're creating a new function because this is now saying, okay, we're really recognizing that x does not equal 4. Because if x was equal to 4, we'd be dividing numerator and denominator by 0, and we can't do that. So right away I see, okay, I'm going to have to, if I want to cancel out 4, I'm now looking at a new function. But the nice thing is the only place where this function is going to be different than this simplified expression that I'm working with is where x equals 4. Okay, so I look at the limit as x approaches 4, and we know that their limits are going to be equivalent because this given expression and my reduced expression, those two expressions agree at all values of x except for one point, that point where x equals 4. So their limits are going to be equivalent. And now I can directly substitute. This new expression, this new function is defined at 4. So we can go ahead and so we can then go ahead and substitute in 4 for x, and we get the expression 4 plus 6 over 4 plus 4. And this gives me 10 over 8, which if you reduce, they each have a common factor of 2. And so then this reduces to 5/4. So our limit as x approaches 4 of x squared plus 2x minus 24 over the quantity x squared minus 16 is going to be 5/4.